Alright, this is Advanced Concepts Presentation 4. We're going to be focusing on generating acetyl CoA from pyruvate. And my name is Jesse Wiskovich. So first off, acetyl CoA acts as a start point as well as fuel for the citric acid cycle. Acetyl CoA is produced from pyruvate through a series of reactions. But where in the first place do we get pyruvate? So going back in the chapter, pyruvate is actually produced in the cytosol through glycolysis. So we have one glucose molecule entering through glycolysis, and then we'll have two pyruvate molecules as the end product. And so then we'll have to move these pyruvates from the cytosol into the mitochondria. Then where does the reaction take place to get acetyl CoA? So once again, we have to move the pyruvate from the cytosol through protein in order to enter into the mitochondria, and then we'll get later on into the matrix of the mitochondria. Now the enzymes involved, we'll have three main enzymes. So the first one is going to be pyruvate dehydrogenase. The second enzyme is going to be dihydrolipoyl transacetylase, and the third enzyme is going to be dihydrolipoyl dehydrogenase. And now together, these three enzymes will form the pyruvate dehydrogenase complex. And then the cofactors involved, there's going to be 5 total. So we're going to have thiamine pyrophosphate, TPP, which is also known as vitamin B1. We have FAD, which is also known as vitamin B2. We have NAD, which is also known as vitamin B3. CoA, which is vitamin B5. And we also have lipoic acid. So the steps of conversion from pyruvate to acetyl CoA will go through decarboxylation, then oxidation, and then transfer of acetyl CoA. Now we're going to go through the very complex pyruvate dehydrogenase complex. So this consists of the 3 proteins, the 3 enzymes. So pyruvate dehydrogenase, then we have dihydrolipoyl transacetylase here, and then the third enzyme, we have dihydrolipoyl dehydrogenase here. Then we have the 5 coenzymes. So we have TPP up here, which is also known as vitamin B1. Then we move over to FAD, which is vitamin B2. We have NAD over here, which is vitamin B3. Coenzyme A is up here, which is vitamin B5, and then lastly we have lipoic acid. So moving through this complex, let's see. So firstly, pyruvate dehydrogenase with TPP as coenzyme carboxylates pyruvate. So we get CO2 pushing off, and then we'll have hydroxyl TPP. And then the dihydrolipoyl transacetylase catalyzes the conversion of hydroxyethyl TPP. Then we get acetyl lipoalamide. And then that transfers to the acetyl group to coenzyme A to produce acetyl CoA, seen here. Now the dihydrolipoyl dehydrogenase over here is going to catalyze the conversion of reduced lipoamide into the oxidized lipoamide down here, transferring the reduced equivalents of FAD, and this completes the cycle of FADH2 over here, in turn transferring and reducing the equivalents of NAD plus to give NADH and a free hydrogen, which will enter the respiratory chain to give us 2.5 ATP by oxidative phosphorylation, and that's later on in the ETC, electron transport chain. So overall, it's a very distinct complex. So the pyruvate dehydrogenase complex will take pyruvate at the beginning, go through a series of enzymes with coenzymes working together, and then that's how we get CoA to form acetyl CoA. So next, these are my sources. I mainly pulled a lot of the information from the book, but I also used a lot of the imaging directly from websites, and that's my presentation. If you have any questions or comments, let me know, and I'll definitely be happy to answer them. So Just let me know if you guys have anything you want me to explain further and leave a comment below. Thanks. Bye.